Hello. In this podcast, we're going to take a look at the quantities weight and mass, and we're going to learn the relationship between the two, and also how we can calculate the force of gravity given the mass of an object, and vice versa, how we can calculate the mass of the object given its weight or force of gravity. Let's get started. Weight and mass, what's the difference? They are different. Mass is an object's resistance to changing its state of motion. We also know that as inertia. It's measured with a balance. It can either be an analog balance or a digital balance. The SI unit for mass is kilogram, and this abbreviation for kilogram is kg. On the other hand, weight is the force of gravity acting on an object's mass. It's measured with a scale. It can be an analog scale like our spring scales, or it can be a digital scale. The SI unit for weight is kilogram times meter per second squared, or we give that a special name, Newton, in honor of Sir Isaac Newton. Weight and mass are related, and this is a very important, simple but very important equation. An object's weight, or its force of gravity, is equal to 9.8 newtons per kilogram times the mass of the object. The 9.8 newtons per kilogram in the equation is a measure of how strong Earth's gravity is. Now, Earth's gravity gets weaker as you move away from the surface into outer space. So this equation with the 9.8 in it is good on or near the surface of the Earth. And when I say near, we can be several miles up into the sky, 5, 10, 15, 20 miles, that would be okay. But if we start getting further away, like where satellites orbit or the International Space Center orbits, this number is going to be smaller. So that's our equation for weight. And of course, if we know the weight, we can find the mass. All I did was take this equation and rearrange it to solve for mass, and the mass is equal to the weight divided by 9.8 newtons per kilogram. Again, this equation is good on or near the Earth's surface. Let's practice using these two equations. So I have them up here for our reference. First, a person has a mass of 100 kilograms. What is his or her weight? Well, we're going to use this form of the equation because it's set up to solve for weight, and we'll plug the 100 kilograms in for mass, and we wind up with 980 newtons is this person's weight. Now, suppose we have the weight. A pro football lineman weighs 1,400 newtons. What is his mass? Well, we're going to use this version of the equation since it's set up to solve for mass, and we're going to plug 1,400 newtons up here in place of the weight, and that tells us that the mass of this lineman is 142.9 kilograms. Well, this ends our short lesson on mass and weight. I hope you found this helpful, and have a good day.